I imagine lying alone on a frozen fjord in northern Norway, the silence so complete you can hear your own heartbeat. The temperature is 30 degrees below zero, the air burns your throat, and then, without warning, the entire sky explodes into silent rivers of emerald, violet, and blood-red fire. The aurora does not flicker, it roars across the heavens like a living thing, curling, twisting, reaching down as if trying to touch you. In that moment you feel impossibly small and impossibly connected, because those lights are not born on Earth. They are the sun's breath brushing our planet from 93 million miles away, proof that our star is alive, restless, and right now surging with power we barely understand. If you have ever stood beneath an aurora and felt your chest tighten with wonder, pause this video for a second and tell me in the comments where you were and what it felt like. While you're here, think about hitting subscribe. Moments like these are why we keep looking up. Most mornings we greet the sun without a second thought. It rises, it warms, it sets. We treat it like the most reliable thing in the universe. Yet hidden beneath that calm golden light is a sphere of unrelenting nuclear fury. Every single second, the core of the sun fuses 600 million tons of hydrogen into helium, converting 4 million tons of matter into raw energy that floods outward in an 8-minute sprint to Earth. That energy has driven every summer, every harvest, every sunrise humans have ever known for 4.5 billion years. And for almost all of that time we believed the sun was steady, eternal, unchanging. Then, 15 years ago, it nearly stopped. Between 2008 and 2009 the sun entered the deepest activity minimum in a century. Sunspots, those dark magnetic knots of concentrated magnetism that pepper the solar surface at the peak of every 11-year cycle, almost vanished. For 736 days across those 2 years the solar disk was completely blank more than 80% of the time. Entire months passed with no spots at all. Satellites recorded the weakest solar wind in the space age had ever measured. The sun's outer atmosphere, the corona, cooled and thinned. Ultraviolet output dropped. Some researchers began to speak openly about the possibility of a new grand minimum, a centuries-long slumber like the Maunder minimum between 1645 and 1715, when sunspots were so rare that European winters grew brutally cold and the River Thames froze solid enough for frost fairs. People started asking uncomfortable questions. Could a quieter sun cool the Earth? Would crops fail? Would the aurora disappear for generations? The uncertainty was real, but the sun had other plans. Instead of drifting deeper into silence, it began to wake up and every forecast. New studies, published only weeks ago, reveal that solar wind speed, density, and magnetic strength have all risen dramatically compared to the feeble cycles of the early 2010s. Depending on the metric, the increase ranges from 6% to a staggering 45%. The river of charged particles that constantly streams from the sun is stronger, faster, and more turbulent than almost anyone predicted when Cycle 24 limped to its exhausted end. Our star did not accept retirement. It is roaring back to life. And it just proved it. 2 nights ago. At 1 minute past midnight Eastern Time on December 8th, a vast tangle of magnetic field lines on the sun's eastern limb snapped like an overstretched steel cable. In less than a second, pent-up energy equivalent to billions of nuclear bombs erupted in a blinding M-class solar flare. NASA's Solar Dynamics Observatory, orbiting silently above the night side of Earth, recorded the entire event in multiple wavelengths at once. On screen, the flare appears as a sudden blossom of pure white fire, so intense it briefly saturates the instruments. Ultraviolet and X-ray radiation flooded outward at the speed of light, reaching Earth 8 minutes later and bathing the entire day side of our planet in invisible fire. That single flare was not an isolated tantrum. It came from one of several hyperactive sunspot groups that have dominated the solar disk for weeks. The most prolific offender, officially labeled Active Region 4294, is larger than 10 Earths lined up side by side. Its magnetic architecture is so complex and unstable that it has already unleashed a barrage of smaller flares and, more ominously, 52 coronal mass ejections in a single week. Each CME is a billion-ton bubble of magnetized plasma hurled into space at speeds that can exceed 2 million miles per hour. When one of those clouds has Earth in its crosshairs, the consequences ripple effects reach every corner of our technological civilization. Right now another threat is bearing down on us. A trans-equatorial coronal hole, a vast dark gash in the sun's corona stretching from pole to pole like a canyon carved across the solar equator, has rotated to face Earth directly. Coronal holes are regions where the sun's magnetic field opens into interplanetary space, allowing solar wind to escape at double or triple the usual speed. The high-speed stream now racing toward us is expected to arrive any day, compressing Earth's magnetosphere, shaking it like a sail in a storm, and very likely igniting auroras so bright and so far south that millions of people who have never seen the northern lights in their lives might suddenly look up and witness the sky on fire. This is not the gentle son of childhood storybooks. This is a star in the prime of a new and unexpectedly powerful cycle, flexing muscles we thought had begun to weaken. And the most breathtaking truth of all: Solar Cycle 25 has only reached its halfway mark. The peak, the real crescendo, still lies ahead. We are living through the awakening of a star, and it is speaking to us in light, in fire, and in shimmering curtains of green across the polar skies. The question is no longer whether the sun will surprise us again. The question is how brightly, how violently, and how beautifully it will do so next. The sun never truly sleeps, it only pretends. Even during the quiet years we thought it was fading, deep inside its churning plasma ocean, magnetic fields were still twisting like invisible serpents, coiling tighter and tighter beneath the surface. Those fields are born in the tachocline, a thin shear zone where the sun's radiative core ends and the convective zone begins. There, rotation speeds change abruptly, stretching and winding magnetic lines the way a child twists a rubber band until it knots. When the tension finally becomes unbearable, those knots erupt upward through 30,000 miles of searing gas and burst into view as sunspots, dark only because they are a few thousand degrees cooler than the blinding surroundings. Each sunspot is a magnetic storm in its own right. Inside the largest ones, field strengths reach thousands of times stronger than Earth's gentle shield. Those fields suppress convection, creating cooler islands that look black against the solar photosphere. But the real violence happens above them, in the corona, where the same tangled lines reconnect in sudden, catastrophic releases of energy. That is exactly what happened on December 8th. The flare we witnessed was not a random spark, it was the magnetic equivalent of a lightning bolt striking inside a thunderstorm that never ends. Solar flares are ranked on a letter scale the way hurricanes are ranked by category. C-class flares are gentle puffs, M-class flares are serious, and X-class flares are civilization-altering monsters. The December 8th event peaked in the middle of the M range, strong enough to ionize the upper atmosphere over the sunlit hemisphere and cause brief radio blackouts across the Atlantic. Pilots flying polar routes heard static swallow their high-frequency channels, search and rescue beacons flickered. For a few minutes the day side of Earth was electrically louder, the D layer of the ionosphere swollen with fresh electrons born from solar X-rays traveling at the speed of light. Yet flares themselves are only the opening act. The true heavyweights are the events that paint the sky and rattle satellites are coronal mass ejections. When magnetic reconnection happens low in the corona, it can launch an entire arcade of loops outward in a billion-ton plasmoid. 52 of these were recorded last week alone, an almost frantic pace. Most missed Earth, sailing harmlessly into the darkness, but every miss is also a reminder of how narrow our margin is. A direct hit from even one moderate CME can compress the magnetosphere on the day side from its usual 10 Earth radii distance all the way down to geostationary orbit, exposing satellites we depend on every day to raw solar wind. Right now the most immediate visitor is not a CME but a high-speed stream from the trans-equatorial coronal hole. Coronal holes appear dark in extreme ultraviolet because plasma is thinner there. Magnetic field lines do not loop back to the sun but stretch out into interplanetary space like hair blowing in wind. Particles spiral along those open lines and accelerate to 800 kilometers per second or more, twice the normal solar wind speed. When that wind slams into Earth's magnetic field, it triggers what scientists call a co-rotating interaction region, a pressure wave that rattles our shield for days at a time. Auroras follow within hours, sometimes within minutes. Picture the magnetosphere as an invisible teardrop wrapped around Earth, stretched a few 100,000 miles downwind by solar pressure. Normally the day-side boundary sits quietly. When a high-speed stream arrives, that boundary is shoved inward, bow shock flares, and the entire cavity rings like a bell. Charged particles spiral down reopened field lines over the poles, collide with oxygen and nitrogen, and the sky ignites. Green from oxygen at lower altitudes, red from oxygen higher up, purple and pink from nitrogen. The palette of the aurora is the periodic table set on fire. What makes this particular coronal hole remarkable is its sheer size and position. Stretching from pole to pole and crossing the solar equator, it resembles a vast magnetic wound. Earth is threaded straight through its outflow like a bead on a wire. Forecasters expect the stream to arrive within the next 48 hours and persist for most of a week, long enough for multiple waves of aurora to sweep across Canada, Scandinavia, Alaska, and quite possibly the northern United States. Cities that almost never see the lights, Minneapolis, Glasgow, Moscow, might find their night skies dancing. But there is a deeper story here, one that stretches back through centuries of human curiosity. For most of history we could only watch sunspots with the naked eye during sunrise or sunset when the glare was dimmed by thick air. Chinese astronomers recorded them as early as 165 BCE. Galileo turned his new telescope on the sun in 1611 and saw the spots move day by day, proving the sun itself rotated. Almost immediately arguments erupted. If the sun was blemished, could it still be perfect as Aristotle had claimed? The discovery helped topple an entire worldview. By the 19th century, a German pharmacist named Heinrich Schwab noticed something extraordinary. After sketching sunspots every clear day for 17 years, he realized their numbers rose and fell in a roughly 11-year rhythm. The solar cycle was born. We now know that rhythm is driven by the sun's magnetic dynamo, a self-sustaining engine that reverses polarity every 11 years and completes a full magnetic cycle in 22. When the field is orderly, sunspots are scarce. When it becomes chaotic, the sun rages. Solar cycle 25 is the 25th such wave since Schwab's counting began. What no one expected was how dramatically the sun would rebound after its near hibernation. Models built on the weak cycles of the early 21st century predicted a gentle cycle 25, perhaps even weaker than the last. Instead, monthly sunspot numbers have been running 20 to 50% above forecast for 3 years straight. The magnetic complexity of active regions is higher, the flares more frequent, the CME rate climbing. Some researchers now speak of a modern maximum that could rival the great cycles of the mid-20th century when astronauts first walked on the moon and the sky over Hawaii blazed with aurora visible from sea level. And we are not passive spectators anymore. Orbiting sentinels like the Solar Dynamics Observatory, the Solar Orbiter, and Parker Solar Probe are rewriting textbooks in real time. Parker has already flown through the corona itself, tasting plasma at the very source of the wind. It measured magnetic switchbacks, sudden reversals that whip particles to supersonic speeds. Those switchbacks are now thought to be one of the engines behind the unexpectedly strong solar wind we measure today. Every new dataset deepens the mystery. Why did the sun fall so quiet, and why has it now overcompensated? Some scientists point to long-term oscillations, century-scale waves superimposed on the 11-year cycle. Others suggest the dynamo itself changed behavior after the 2008 minimum, perhaps because conveyor belt flows deep inside the sun sped up or shifted latitude. A few even wonder whether we are seeing the first stirrings of a new grand maximum, a centuries-long era of high activity like the one that coincided with the medieval warm period. Whatever the cause, the consequences reach far beyond pretty lights in the sky. Solar storms can induct currents in power grids. The Carrington event of 1859 melted telegraph lines and sparked fires. A similar storm today could cause trillions of dollars in damage and leave entire continents dark for months. Satellites can be blinded or killed outright. Airline crews and astronauts receive dangerous doses of radiation. Yet the same magnetic turmoil that threatens our technology is also the brush that paints the aurora, the force that gave Earth its protective shield in the first place. We live on a magnetic planet orbiting a magnetic star, and the conversation between the two is written in fire and light. Right now that conversation is growing louder. The sun is not trying to harm us, it is simply being itself, a restless sphere of plasma that has burned for 4.5 billion years and will burn for 5 billion more. Our job is to listen, to understand, and when the sky ignites, to look up and wonder rather than fear. Because somewhere above the Arctic Circle tonight, someone who has never seen the northern lights before is about to step outside, tilt their head back, and feel the universe touch their face. And in that shared moment of silent green fire, we remember that we are not separate from the cosmos. We are made of it, lit by it, and sometimes, when the sun speaks loudly enough, danced with by it. The stream from the trans-equatorial hole is already here. As I speak, particles that left the sun 3 days ago are threading through Earth's magnetic shield at nearly 2 million miles per hour. The magnetosphere is singing, stretched and vibrating like a drumhead. Over northern Canada, curtains of green as glacier ice are unfurling from horizon to horizon. In Scotland, people are pulling over on dark country roads, engines still running, mouths open. Someone in Minnesota just woke their sleeping child, carried her outside in pajamas, and watched her first aurora paint silent fire across the Big Dipper. None of them will ever quite be the same. That is the gift hidden inside every solar storm, the sudden, undeniable reminder that the sky is not a ceiling. It is an ocean, and we are swimming in it. We spend most of our lives looking down, at screens, at sidewalks, at the small circles of light we build to keep the dark away. Then the sun flares, the wind races across 93 million miles of vacuum, and for one night the dark becomes the brightest thing we have ever seen. In that moment the distance collapses. A star that could hold 1,000,000 Earths reaches out and brushes your retina with its own plasma, and you feel chosen, fragile, alive. But there is another side to the gift, one we rarely talk about until it is too late. The same forces that create beauty can also break the thin technological shell we have wrapped around the planet. Every transformer humming in every substation, every GPS satellite keeping planes in the sky, every undersea cable carrying half the world's internet traffic, all of it is quietly, constantly, negotiating with the mood of a star. And right now that star is wide awake. Forecasters are watching the next batch of active regions as they rotate into view. The magnetic complexity is rising again. Another M-class flare is probable within days. An X-class event is no longer a question of if, but when. When it comes, the sky will answer with auroras so fierce they may reach the Caribbean. And somewhere on the night side of Earth, engineers will scramble to safe-mode satellites while power grid operators hold their breath. We have never been this connected and never this vulnerable at the same time. The Carrington event of 1859 remains the benchmark. Auroras so bright people in Hawaii read newspapers by their light at midnight, compass needles swung uselessly, telegraph operators received shocks from their keys. If the same storm struck today, studies estimate hundreds of extra high-voltage transformers could fail across North America and Europe. Recovery could take years and cost trillions. Yet the probability is not hypothetical. Storms of that magnitude arrive roughly once per century. We are overdue. The difference is that this time we can see it coming. Space weather centers in Boulder, Brussels, Moscow, and Beijing are lit 24 hours a day. Satellites phone home every few minutes with fresh images of the solar disk. Machine learning models digest magnetograms and predict flare odds the way meteorologists predict rain. When the big one launches, we will have anywhere from 20 minutes to 3 days of warning, enough to raise shields, throttle grids, and park satellites in safe orbits. That narrow window is the triumph of centuries of curiosity. It began with Chinese scribes noting black vapors on the sun, continued with Galileo squinting through smoked glass, and now lives in the quiet hum of servers translating magnetic chaos into probabilities. Every frightened question humans ever asked about the lights in the sky has led to this moment. We are no longer helpless beneath the storm. We are learning to dance with it. And that is the deeper truth solar cycle 25 is teaching us. The sun is not our master and not our enemy. It is our companion, vast and wild and older than continents, reminding us every 11 years that stability is an illusion and change is the only constant. It burns away our smallness and replaces it with perspective. 4,000,000 tons of itself vanish into light every second so that a thin film of air on a blue marble can host music, laughter, and the slow unfolding of minds that eventually learn to read the handwriting of stars. So when the next aurora blooms over your city, step outside. Turn your face to the sky and let the light of an alien fire wash over you. Feel the cold on your cheeks and the warmth in your chest at the same time. Somewhere behind those dancing curtains, a star you will never touch is spending its life to keep you alive. And for one brief, blazing moment, the distance between you disappears. We are children of a restless Sunday, we always have been, and tonight, it is speaking our name in colors no human hand could ever mix. Thank you for sharing this journey with me. If the sky ever sets itself on fire above your home, come back here and tell us what it felt like. Until then, keep looking up. The next act is already beginning. The light fades, the curtains dissolve into dawn, and the world returns to its ordinary colors. But something lingers. A faint taste of ozone in the air, a memory of green fire behind your eyelids, the sudden certainty that the universe is far less distant than you believed yesterday. That feeling is not imagination. It is physics. Trillions of protons and electrons that were, only days ago, part of the sun's outer atmosphere are now raining gently through the top of Earth's sky, losing their energy in silent collisions that leave no mark except on the human heart. Long after the last aurora has vanished, those particles will continue to circle the planet in the Van Allen belts, trapped in Earth's magnetic embrace like ghosts of the storm. This is the quiet aftermath no camera ever captures. While headlines move on and notifications flood back in, the sun keeps speaking in a language older than words. Every flare, every CME, every high-speed stream is a syllable in a conversation that began when the first oceans condensed and will not end until the sun itself swells into a red giant 5 billion years from now. We have only just learned to listen, and already the story is changing us. Look at what we have already built because of it. Solar observatories in space and on mountaintops. Global networks of neutron monitors watching for the ground-level showers that arrive when the most energetic storms breach our shield. Quiet rooms where mathematicians translate chaos into probability so that a pilot over the Arctic can be rerouted before radiation spikes. All of it born from the same impulse that once made ancient people paint reindeer beneath dancing lights on cave walls in Lascaux. We saw the sky move, and we needed to understand. That impulse is not finished with us. Solar cycle 25 still has years to run, and every month the forecasts are rewritten. The sunspot groups now crossing the disk are larger, more twisted, more eager than almost any seen since the space age began. Somewhere inside those dark umbra, magnetic ropes thicker than worlds are braiding and unbraiding, storing energy equivalent to every nuclear weapon ever built, multiplied 1,000,000 times over. When the moment they snap, the next chapter begins. We will watch it together. Not just scientists in control rooms, but all of us. Phones will light up with alerts. Children will be pulled from beds again. Strangers will stand shoulder to shoulder on frozen lakes and city rooftops, breath fogging, eyes reflecting colors that have no name in any earthly language. And in that shared silence we will remember, without anyone needing to say it, that every atom in our bodies was once inside a star, and tonight a star has reached out to welcome its wanderers home. So keep your coat by the door, keep your curiosity sharp, the sun is not done surprising us. It never will be. Because out there, 93 million miles away, a sphere of fire 4.5 billion years old is turning itself inside out in slow motion, just to remind a small blue planet that it is loved in the only way a star knows how, by burning, fiercely, endlessly, beautifully, and we brief sparks flung outward from that burning, are finally learning to burn back, with wonder, with questions, with cameras pointed at the sky and comments filled with exclamation points at 3 in the morning. That is the real solar maximum. Not the moment a species looks at its parent star and, for the first time, sees not a god, not a threat, but a companion. Thank you for staying until the lights went out. The next time the sky ignites, I'll be right here, ready to watch it with you again. Until then, clear skies, open eyes, and may every sunrise feel a little less ordinary than it did before.